multiple choice questions on set of real numbers. The first question is find the solution set of the set A is equal to collection of all real numbers such that x greater than thrice x plus 4 is equal to 2 to infinity. Option number A 2 to infinity, option number B minus infinity to 2, then option number C minus infinity to minus 2, and option number D minus 2 to infinity. So here the given inequality is x greater than thrice x plus 4. So this implies 4. If you subtract 4 from both sides, we get x minus 4 greater than thrice x, and if we subtract the x from both sides, we get the minus 4 greater than thrice x minus x, and this implies thrice x minus x is twice x is less than minus 4, and this implies if we divide both side by 2, then we get x less than minus 4 by 2, that is minus 2, and therefore the x less than minus 2 implies the solution set is minus infinity to minus 2. So the correct option is what? Minus infinity to minus 2. The correct option is what? Option number C. Then example number 2, find the solution set of A is equal to collection of all real numbers such that x square greater than thrice x plus 4 is equal to, the option number A is 4 to infinity, option number B minus infinity to minus 1, option number C 4 to infinity union minus infinity to minus 1, minus, and D, or you can write this as this option number C can be written as union 4 to infinity, option number D is equal to say minus infinity to plus infinity. So here x square greater than, the given inequality is x square greater than thrice x plus 4. This, if we write this inequality can be written as x square minus thrice x minus 4 greater than 0. So this implies this is a quadratic equation in x. So this is what x minus 4, its solution is x minus 4 x plus 1 greater than 0. Now when the product of two term is greater than 0 if case number first x minus 4 greater than 0 and x plus 1 greater than 0, or x minus 4 is less than 0 and x plus 1 is less than 0. So this implies x greater than 4 and x greater than minus 1, or x less than 4 and x less than minus 1. So this implies now x greater than 4 and x greater than minus 1 implies x greater than 4. The solution of these two equation is what? If we take the intersection of these two solution is what? X greater than minus 1, say here minus 1 and here 4, then x greater than x greater than minus 1 and x greater than 4. So the common solution is what? X greater than 4, and x less than 4 and x less than minus 1 implies x less than minus 1. So here the solution set of this for this condition is 4 to infinity and here minus infinity to minus 1. So the solution is what? 4 to infinity union minus infinity to minus 1. So the correct option is what? 4 to infinity union minus infinity to minus 1, option number C. Next example number 3. Solve for any real number, let ABC let a b c be any real numbers, any real numbers, and if a greater than b and b greater than c, then option number a less than c, option number b a greater than c, option number d a is equal to c, or option a b c, or option number d none. So here a greater than b, now since a greater than b implies a minus b is greater than 0, and this implies a minus b is a positive real number. Similarly, b greater than c implies b minus c is greater than 0, implies b minus c is also a positive real number, and by using uh, properties of positive real number set, we can write this as a minus b plus b minus c is also greater than 0. Sorry, here not, b minus c is also greater than 0. We know that if a belongs to in positive real number and b is also positive real number, then their addition is also positive real number. So this b will get cancelled here, and a minus c is greater than 0, and this implies a is greater than c. So the correct option is what? A greater than c, option number b. The next option number next example is, if a and b are any real number, a b c are any real numbers, a b c be any elements of set R, set of real numbers, and if a greater than b and c greater than 0, then option number a ac less than bc, option number b ac greater than AC greater than BC, option number C AC is equal to BC, or option number D none. So here A greater than B and C is greater than 0, then we know that now since A greater than B implies A minus B is greater than 0, and this implies A minus B is lie in positive real number set, and since C is also greater than 0, C also lie in positive set of real number, and since A minus B is positive real number, C is also positive real number, this implies their product A minus B into C is also lie in set of positive real number, and this implies AC minus BC is greater than 0, and this implies AC greater than BC. So the correct option is what? AC greater than BC. Similarly, if ABC are any real numbers, ABC, next example, say ABC are any real number with A greater than B and C less than 0, then option number A is AC less than BC, option number B AC greater than BC, option number D AC equal to BC, or option number C D is none. So the again, since C is less than 0 implies and A is greater than B, for example we know that 2 is, say 3 is greater than 2 and take C is equal to minus 5, then the minus 15 is less than minus 10. So the correct option is what? AC is less than BC. Now the next example, find find or the twice x plus 9 equal to 15 is equal to option number A x is equal to 3, option number B x is equal to 3, x is equal to minus 6, option number A, B, C x is equal to 6 and x is equal to minus 12, and D x is equal to 3, x is equal to minus 12. So here we know that the solution of mod of x is equal to a has two solutions, plus or minus x is equal to a, or x is equal to, or x is equal to plus or minus a. So by using this we can write this as, this twice x plus 9 can be written as twice x plus 9 equal to 15, or twice x plus 9 equal to minus 15. So if we solve this, we get twice x plus 9 equal to 15 implies twice x is equal to 15 minus 9, or twice x is equal to minus 15 minus 9. So this implies twice x is equal to 6, or twice x is equal to minus 24. So this implies x is equal to 3 and x is equal to what? Minus 12. So the correct option is what? X is equal to 3 and x is equal to minus 12. So the correct option is what? Option number D. Now if A, B, C are any real numbers, next example, if A, B, C are any elements of set of real numbers, say real number R, set of real number set R, and if A greater than B, then option number A plus C is greater than B plus C, B, A plus C is less than B plus C. Option number D, is say A plus C is equal to B plus C, option number C, and option number D is none. So again we know that if A is greater than B, and if C is any real number, then A plus C is greater than B plus C. So this is what the correct option is what? Option number A. Now the next example, what is the answer of modulus 2 plus modulus of minus 2 is equal to? And the options are given: A is equal to 2, B is equal to 0, C is equal to 4, and D is equal to minus 2. So here absolute value of mod 2 is equal to 2 and absolute value of minus mod 2 is equal to again 2. So mod of 2 plus mod of minus 2 is equal to 2 plus 2, which is equal to what? 4. So the correct option is what? Option number C. The next example, the supremum, if A is equal to 2 plus 1 by n, where n is a natural number, is a set of natural number, then option number A, supremum of A is equal to 1 and infimum of A is equal to 2. Option number B, supremum of set A is equal to 3 and infimum of set A is equal to 2. C, supremum of set A equal to 2 and infimum of set A is equal to 1. Then option number then D, supremum of A is equal to 2 and infimum of A is equal to what? 0. So here if we write some elements of this set A, then we get 2 plus 1, then 2 plus 1 by 2, 2 plus 1 by 3, 2 plus 1 by 4, 2 plus 1 by 5, 2 plus 1 by 6, and so on. So here you can see here the first element is what? 3, that is 2.5, 2.3, then 2.2, 2.1, 2.0001, and so on as n increases. So here the supremum of A is 3 and this sequence is this sequence is what? Decreasing sequence, and its limiting point is what? 2. So the here supremum of A is equal to 3 and infimum of A is equal to 2. So the correct option is what? Supremum is A and infimum is equal to what? 2. The next example, if A is a subset of B, say option number, if A is a subset of B, then the option number A, impim of A is less than or equal to impim of B. Impim of A greater than impim of B. Impim of A is greater than or equal to impim of B. Option number C. The impim of A is equal to impim of B, and option number D, none of these. So A is a subset of B. For example, if we take the simple example, say here A is equal to say 2, 3, 4, and B is equal to say 0, 1, 2, 3, 4, 5. So here A is a subset of B, and impim of A is equal to what? The impimum of set A is equal to 2, and impimum of set B is equal to 0. So here impimum of A is greater than or equal to impimum of B. So the correct option is what? Impimum of A is greater than or equal to impimum of B. So when equality hold, if we take say here A is equal to 1, 2, 3, A is equal to 1, 2, 3, and B is equal to say again take say 1, 2, 3, 4. So here impimum of A and impimum of B, A is a subset of B, but impimum of A is equal to what? Impimum of B. So the correct option is what? Impimum of A greater than or equal to impimum of B. And then next the next example, if A and B are any two real numbers, if A and B be any two real numbers, say real numbers, be any two elements of the set of real numbers, then option number A, mod of absolute value of A plus B is greater than or equal to absolute value of A plus B. Option number B, mod of A plus B is equal to mod of A plus mod of B. Option number C, mod of A plus B is less than or equal to mod of A plus mod of B. And option number D, none of these. So the correct option is what? Again we know that triangle inequality, the mod of A plus B is less than or equal to mod of A plus mod of B, or in other words we know that minus of mod A less than or equal to A less than or equal to mod of A, and minus of mod B less than or equal to B less than or equal to mod B. So if we add these two equations, we get minus time mod A plus mod B less than or equal to A plus B less than or equal to mod of A plus mod of A plus mod of B. So if we know that from this two inequality we can write, we know that if minus A less than X less than or equal to A, and if A is greater than 0, then we can write this as mod of X less than or equal to A. So here we can write mod of A plus B less than or equal to mod of A plus mod of B. So the correct option is what? Mod of A plus B less than or equal to mod of A plus mod of B. The next example, if A and B be any two elements, if A and B be any elements of set of a real number R, then number first, mod of A minus B is greater than or equal to mod of A plus mod of B. Option number B, mod of A plus B, A minus B less than or equal to mod of A plus mod of B. Option number C, mod of A minus B is equal to mod of A plus mod of B. And option number D, none of these. So the correct option is what? If A and B are any real numbers, then now by using previous inequality we know that from triangle inequality the mod of a plus b is less than or equal to mod of a plus mod of b. So in this inequality, if we put here in place of plus, if we write it as a minus here, then this becomes in place of b, if we write here, if we replace b is equal to minus b, then a of minus a mod of a minus b less than or equal to mod of a plus mod of minus b. But mod of minus b is same as mod of b, as minus mod of b is same as mod of b. From this we can write mod of a minus b less than or equal to mod of a plus mod of b, and hence the correct option is what? The this option number B is the correct option.